Comes to section 5.3, we're going to be looking at polynomials, or graphs of polynomials rather. So for instance, when we talk about the graph of a polynomial, the graph of a polynomial is going to be a smooth curve with no sharp corners or edges. And it's going to be a continuous curve. What do we mean? So for instance, when we talk about continuous, we're saying that you can draw the graph without lifting your hand. Okay, so this is going to be a continuous function, or a continuous graph rather. So what does that mean? That means that this is a polynomial. So we don't have to lift up our hands when we draw it, and notice that there is no sharp curve or edges. Additionally, h is the same way. When we draw it, we don't have to lift our hands. And also there is no sharp curve or edge. So this is also the graph of a polynomial. However, if you look here, there's a sharp V. Because of that, this is not the graph of a polynomial. And if we look here, if we were to draw K, notice what? If I were to finish this, I have to lift my hand and then finish the graph. So this is not continuous, hence it's not the graph of a polynomial. So these are how you can determine what a graph of a polynomial looks like, or these are the characteristics of the graph of a polynomial. Now, what we're going to be looking at is using factoring to find the zeros of polynomials. So we've been looking at the zeros of polynomials before. And when we talk about zeros, I want us to recall that we're talking about the x-intercept. We're talking about the solution of the equation when you set it equal to 0, as well as your zeros, okay? So let's say, for instance, we get a problem where we're asked to find the x-intercept of f of x equals x to the 6th power minus 3x to the 4th power plus 2x squared. So again, recall that if you're finding your x-intercept, your y is going to be 0. So if I were to rewrite this function, I would have f of x equals x squared minus 3x, rather x to the 6th power minus 3x to the 4th plus 2x squared. So what does this mean? If I'm finding the x-intercept, I'm going to be setting y equals to 0. And then I'm going to try to solve for x. Now, if you notice, all of these have x in common, and specifically, each of these have x squared. If I were to look at, let's say, x to the 6th power, right? It means we have 6 x's, and I were to pull out x squared, then I'll be left with x to the 4th. So let me record that. So if I factor out x squared here, for the x to the 6th, I will be left with x to the 4th power. Then if it were x to the 4th and I pulled out these two, what am I left with? Well, I'm left with x squared. And then here, if I pull out x squared, then I'm just left with 2. Okay. So here I have that 0 is equal to x squared times x to the 4th minus 3x squared plus 2. So what does that mean? Since we're having two things multiply to give us 0, that means either x squared equals 0 or x to the 4th minus 3x squared plus 2 equals 0. So if we look at the first one, if x squared is equal to 0, we'll take the square root of both sides. So that means x is equal to what? 0. But notice that it has a power of 2 or a multiplicity of 2. So this would be 0 twice. Next, let's say we want to get the solution for this. Well, recall how we would factor a quadratic, right? So if we have a quadratic, it's in the form ax squared plus bx plus c equals 0. So in this instance, though, it's not x squared, but we will do the same thing that we would do if we were doing x squared. So we need two numbers that multiplies to give us a times c. In this case, that's going to be 1 times 2, which is equal to 2. And the sum is -3. So you could possibly pause the video and try to figure it out, but this should be -2, -1. Because if I do -2 times -1, I'll get a +2. And if I add the 2, I'll get a -3. So recall what we would do is we would now do our parentheses and do, what do you call it? Our factors. Actually, we would rewrite this as x to the 4th minus 2x squared plus, minus 1x plus 2 equals 0. And this should be a square here. Now, we're just going to proceed the same way by looking at what's common to these two terms. So we see that x squared is common. Similarly, using the same method that we had up here, if I plotted x squared out of x fourth, I'm going to be left with x squared. Then if I plot x squared here, I'm going to be left with -2. Then here, what's common? We don't really see a number that's common. So when that's the case, we can pull out 1. But notice that I need to have a -2. So I need to pull out not just 1, but -1. And so if I put -1, I'll be left with x squared minus 2 equals 0. Because if you do -1 or -2 divided by -1 will give us a -2. So at this point, we see that we have these two things in common. So we have these two things in common, we can pull them out. So that means we have x squared minus 2. And then here we have x squared left over. And here we have -1 left over. So if we solve these, so we have x squared minus 2 equals 0, or x squared minus 1 equals 0. So if x squared minus 2 equals 0, then x squared equals 2. And that means x will be plus or minus the square root of 2, because you take the square root of both sides. Then here, similarly, x squared equals 1. Take the square root, x equals plus or minus 1. So then my solutions become 0, 0, 1, -1, and then square root of 2, negative square root of 2. And I hope we recall that if we are solving a polynomial or finding the roots, that the degree tells us how many solutions we should have. So since this has a degree of 6, we should have 6 solutions, which we do. So if we wanted to graph this, these intercepts, so let's say this is -1, -2. So then we know that 0, 0 is, or 0 is one of them, positive 1, negative 1. Now, where do we find the square root of 2? Well, the square root of 2 lies between the square root of 1 and the square root of 4, which is 1 and 2. So it's going to be around here. And similarly, negative root 2 will be around here. Okay. So that's how we would factor this problem. Alrighty. So next, let's try another example. So here we have x cubed equals, I'm sorry, f of x equals x cubed minus 5x squared minus x plus 5. In this problem, we see that we have 4 terms. So we could possibly do what we usually do anyways, which is factor by grouping. So what do I mean? We can group the first 2 terms together and then group the second 2 terms. So if I were to rewrite this, I look for what's common between these 2 and then what's common between these 2. So of course, if you're finding the zeros, you're going to set this equal to 0. Alrighty, so now what's common here, like we did before, we can pull out the x squared. Here, if I have 3x being multiplied and I pull out 2 of them, then I'm left with just x. Here, I'll be left with minus 5. Similar to what we did previously, for this one, we would need a negative 5 here. So I'm going to pull out a negative 1 times here. If you do negative x divided by negative 1, I'll get a positive x and then a minus 5. And again, since we have these 2 to be the same, then we can pull those out. And we'll have x minus 5. And we are left with x squared minus 1. So of course, we set each of these equal to 0. So x minus 5 equals 0, which means that x equals 5. And then here we have x squared equals 1. So that means x equals plus or minus square root of 1, which is plus or minus 1. So my solutions become 5, 1, negative 1, which is 3 solution, which is in line with my degree. And if we were to graph this, 5, so negative 1, 1, and 5. All right, so this is how we would solve by graphing. All right, so now we're not only being told to find the x-intercept, now we're being told to find also the y-intercept. So if we want to find the y-intercept, we know that you set x equal to 0. So let me find the y-intercept. That means we're going to be doing g of 0, which is equal to 0 minus 2 squared times 2 times 0 plus 3. So here we're left with negative 2 squared, which is 4, times 3, which is 12. So that's where my y-intercept will be. Now, if I wanted to find my x-intercepts, we'll do what we just did. So we'll have that 0, equals x minus 2 squared times 2x plus 3. The beautiful thing about this is it's already factored. So that means we could just say, well, x minus 2 squared equals 0, or 2x plus 3 equals 0. So here that means that if we take the square root of both sides, we have x minus 2 equals 0. We add 2. So that means x is equal to 2. And this will actually be twice because we had square, which means it was a multiplicity of 2. Then here, we would subtract 3 from both sides. So 2x equals negative 3. Divide both sides by 2, we get that x is equal to negative 3/2. Now, if we wanted to graph this, we would graph the intercepts. Alrighty, so my x-intercepts are 2 and negative 3/2, which would be 1 point something, and 12. Okay, and then you will connect your dots. So we're going to learn how to really connect the dots. But for now, we're just going to connect them. And we know that we looked at the multiplicity. Since this is a multiplicity of 2, it doesn't really go through. It actually is going to bounce. Hopefully we remember that. All right. All right, so now we need to look at zeros and their multiplicity. So I may have went a little bit ahead of myself when we talk about multiplicity. So let's look at it right now then. What do we mean by multiplicity? So I'm going to use a graph to kind of explain. All right, so here we have the graph of f of x equals x plus 3 times x minus 2 squared times x plus 1 cubed. The number of times a given factor appears is called its multiplicity. So for instance, here you see this has 2 or a square. That means we have a multiplicity of 2. Here we see raised to the 3rd power. This means we have a multiplicity of 3. Let's look at how the graph behaves when we have these things. So when we have a multiplicity of 1, so this one will be associated with when x is equal to negative 3. This one will be associated when x is equal to 2. And this one is when x is equal to negative 1. All right, so for these, let's look at when x is equal to 3. Negative 3 rather. So when x is equal to negative 3, we're here. Get another color. Negative 3, we're here. So what does this mean? Well, notice that the graph went through negative 3. So when we have a multiplicity of 1, we're going straight through that point. Then at x equals 2, what do you see happen? We bounced. So when you have an even multiplicity, you're going to do a bounce. So that means you're not going to go through the point. You're just going to bounce off the point. And then when you have a multiplicity of 3, like we do with x equals -1, so we're here, it's going to give us like a little flat, and then it goes through. A little flat. It doesn't go straight through, it gives a little flat, then we go through. And this happens for all odd multiplicities, okay? Meaning we have an odd number for the multiplicity. Okay. So let's generalize this statement just to kind of make it a little bit more solid. So again, if you have a multiplicity of 1, the point is going to go straight through. If you have a multiplicity of 2, it's going to bounce. If you have a multiplicity of 3, it's going to give us a little flat and then go through the point. Okay. So this is just what I just said in words. One thing I also noted was that the sum of the multiplicity, n, is the degree of the polynomial, okay? And the good thing about being on this video is, guess what? You can pause it and take notes if you need to, okay? So here we have a graph, and we're told to use the graph of the function of degree 6 to identify the zeros of the function and their possible multiplicities. So if they're telling us we have a degree of 6, that means we must have all of our multiplicities should add up to 6, okay? So for instance, here, let's look at each of our values. So here we have -3. What do we see happening? So at x equals -3, we see a bounce. So that means we have an even multiplicity, but I'm just going to say 2 for now. If I need to change, then I will. But we know it's even. This one goes straight through. So we know that's going to be a linear or a multiplicity of 1. So for x equals -1, we have a multiplicity of 1. And then if we look here, notice it has a little flat and then down. So at x equals 4, we have a multiplicity of 3. Now, if we add these, 3 plus 2 is 5 plus 1 is 6. So that means these are my correct multiplicities of my zeros. Okay. Now let's look at another example just quickly. So let's look at this behavior that we have. So here, we know that well, it doesn't really, it's not really flat here, right? So at x equals -5, it's not really flat. Actually, it just goes through because it should be flat like a little bit more flat than this to give us an odd multiplicity. So this is going to just be, I'm guessing, because remember here, this is actually supposed to say degree 5. Sorry. So since they told us that this is supposed to be a degree of 5, now I'm just going to leave that one blank. So just so we can come back, because the multiplicity should add up. Here at x equals -1, it's quite obvious that this is a multiplicity of 2 because it bounces. And then here at x equals 3, it also bounces. So now with that being said, If my degree is 5, 2 plus 2 is 4, so that means this must have a multiplicity of 1. And that's my answer. Alrighty. So now what we're going to look at is determinant and behavior. So I really want you guys to observe that what we're doing here is putting all the parts together to graph a polynomial. So here we're asked to determine, or we're going to be looking at how to determine the end behavior of a polynomial. So we looked at the intercepts and we looked at the multiplicity of the zeros. So now we're going to look at the end behaviors. All right, so when we talk about the end behavior, there are two things that we consider when we look at it. So the first thing that we consider is the degree of the polynomial and whether the degree is even or odd. Okay, is the degree even or is it odd? After you look at the degree of the polynomial, you also want to look at, is the coefficient negative or positive? So if you have an even degree and a positive leading coefficient, then both endpoints or end behavior of this graph are going to be facing upwards. If we have a negative coefficient and an even degree, both sides are going to go down. Okay. Now, if we have an odd coefficient, right, and a positive, if we have an odd degree and a positive coefficient, then the right side goes up and the left side goes down. But if we have a negative leading coefficient and still an odd degree, it switches. The left side goes up and the right side goes down. We've looked at this a little bit already, so this should just be a little bit of a reminder. So now what we want to do is understand the relationship between the degree and the turning point. So turning points are going to be another important part of your graphs for your polynomials, right? So we have, again, intercepts, then we have multiplicity over zeros, then we have the end behavior. Now we're going to look at the relationship between the degree and the turning points. So when we talk about a turning point, it's really just where your graph changes from increasing to decreasing or from decreasing to increasing. And you can also count the number of turning points you should have if you know the degree of your polynomial. In other words, if you have a degree of n for your polynomial, then you have at most n minus 1 turning points. So let's see if we can figure out a number of turning points we have for A. And I want to note for you all that we are saying that you may have at most n minus 1 turning points, but you may have less. So when you're given the answer, you want to say at most such and such. Okay? We're not going to say, oh, we definitely know that this is the number of turning points we have, unless we know the graph or we're given the graph. So if you notice A, we're going to look at A first. A is not in standard form. And when we talk about standard form for a polynomial, you have the highest exponent first and the one after that that's less, and so on and so forth. So you put it in descendant order. So f of x should be equal to actually not negative x cubed, but 4x to the 5th power minus x cubed now comes, then minus 3x squared plus 1. So my degree is 5. What does that mean? I have at most 5 minus 1 equal 4 turning points. Now, if we look at this one, we're given the factors, right? So we have to kind of just gauge it and think, if I were to multiply these, so if I were to multiply x squared, 2x squared, so here I have x squared, and then here this would be x squared too. So if I have x squared times x squared, that's going to give me x to the 4th power. So if I have x to the 4th power, my degree is 4. And then I have at most 4 minus 1, which is equal to 3 turning points. Okay. All righty. Okay. So now that we've looked at all of these different things, what we're going to look at next is the actual graph of the polynomial. So again, let's review. We've looked at the intercepts, we've looked at the multiplicities and what happens there. We've looked at the end behavior, and we've looked at the number of turning points. So let's put that all together to see if we can actually graph a polynomial. So here we're asked to sketch the graph of f of x equals -2 times x plus 3 squared times x minus 5. Okay, so first let's look at the y-intercept. So of course, the intercepts are the easiest, so let's look at those first. So for the y-intercept, x is 0, so that means I'm going to be doing f of 0. It's going to be -2 times 0 plus 3 squared times 0 minus 5. What does this become? 3 squared, which is 9. And then -5. So this would be 5 9 45. That's going to be 90. So my y-intercept is 90. Now to find my x-intercept, I said f of x equal to 0. Well, in this case, we already have factors. We know that -2 is not equal to 0. So either x plus 3 squared equals 0, or x minus 5 equals 0. Here you'll take the square root of both sides. So x plus 3 equals 0. So that means x is next, that this is a small 2. So since this is a multiplicity of 2, then we write it twice. And then here we have to add 5. So x equals 5. Okay. All right, so now what we're going to look at is the end behavior. And let me just make sure that this is still recording, because I kind of heard a crazy sound. Yes, we're still recording. Okay. All right, so end behavior. So remember, for the end behavior, we are looking at the leading coefficient as well as the degree. Is it even, odd, or negative or positive? So let's look at that. So our degree here, so this is a square term times x. So my degree is 3. All right, and then if you notice, my coefficient, it is actually there for me already. My coefficient is actually gonna be negative. So with the odd degree and a negative coefficient, that means my left side is up and my right side is down. So let's kind of sketch what we have. And then notice that with the turning points, we should have at most n minus 1, where n is 2. N is 3. 2 turning points. So let me put these in. So we're going to be at negative 3 and 5. Okay. And my y is at 90. I'm just going to put 90 up here. Very good. So the multiplicity of 5 is 1. So we know that it's supposed to go through. And with the fact that this is supposed to be down, so I'm going to draw this down. And then this one actually bounces, right? Because that was a multiplicity of 2. This one has a multiplicity of 1. So it goes through, and then negative 3 is a multiplicity of 2. So it bounces. So my graph looks something like this. And then if you notice, number of turning point is 1. This is a turning point. And 2, this is a turning point. Okay. So this is how you would graph a polynomial. Let's try one more. So let's see. My y-intercept, f of 0 equals 1/4 times 0, 0 minus 1 to the 4th power, 0 plus 3 cubed. But if I notice here, the 0 is on the outside, and 0 times anything is going to give me 0. So 0 is my y-intercept. Now my x-intercept, set in f of x equal to 0. So this means x equals 0, or x plus 1 to the 4th power equals 0, or x plus 3 cubed equals 0. So here, x equals negative 1 has a multiplicity of 4, and x equals negative 3 has a multiplicity of 3. Then for my end behavior, this is going to give me x to the 4th times x cubed times x. So this is going to give me a multiplicity of 8. Not a multiplicity, I'm sorry. A degree of 8. And a leading coefficient that's positive because it's 1/4. What does that mean? That means both endpoints should be facing up. So let's go ahead and graph. So my points are at, oh, sorry. I know you guys are like, how did that become a positive one? It should be a -1 here. So x is equal to 1 is the root. So here is 1. And then -3 is here. My y-intercept is at 0, and so is my x. So let's see what's happening here. For, well, since we're at 1, for x equals 1, we have a multiplicity of 4, which is an even multiplicity. If it's an even multiplicity, it's going to bounce. But this is supposed to go through 0. 0 has a multiplicity of 1, so it goes like so. And then at -3, the odd multiplicity. So remember with the odd multiplicity, you have like a flat, but it does go through. So something like this, both sides up. All right. So this is just me gauging it, okay? So this is how you would come up with the graphs of your polynomials. So the last thing I want to talk about is something else that can help. You may or may not use this often, but if you go further in mathematics, you will. It's the intermediate value theorem, and it's really straightforward. So what the intermediate value theorem tells us is that if you do f of a, f of some value, and it's negative, so it's like below the x-axis, and then you do f of another value and it's above the x-axis, or it's positive, that means there must be some value or some x such that f of x is equal to 0. Or in other words, if your function changes from negative to positive, then the function must go through the x-axis. That's basically what it's saying. So what do we mean specifically? So here it says, use the intermediate value theorem to show that f of x equals x cubed minus 5x squared plus 3x plus 6 has 2 real zeros between x equals 1 and x equals 4. So the way to do this, or one way to do this, you can do a box with your values. So this would be 1, 5, okay, so there we go. How did I get these values? So let's say we wanted to find f of 1. Then I'll plug in 1 cubed minus 5 times 1 squared plus 3 times 1 plus 6. And so we do 1, 2, 3, 4 because they told us x is between 1 and 4. So we go from 1 to 4. So you'll do this again. Then we're going to do it for 3. And you can just plug these straight into your calculator. And then f of 4. Okay, and then once you plug them in, you'll get these values below: 5, 0, -3, and 2. So if you notice, and let me copy this. I'm going to need this. Here we go. So here we have the graph of this function here. So if you notice, let's say 1, 5 is here. 1, 5 is here. That's positive. And then here you have 3, -3. So this is a negative value. So here is 3, -3. This is 1, 5, and this is 3, -3. Basically, you see that -3 is below the x-axis, 5 is above it. So that tells me that there must be some 0 in between these two numbers, since 1 is above the x-axis and 1 is below. Similarly, this is -3. So this is a negative value, so it's going to be below my x-axis. And this is a positive 2. So that's going to be above my x-axis, right, which is here, 4, 2. That means there must be a 0 in between. Since my function has to be smooth, or in other words, has to be continuous, then I must cross the x-axis. That's really what the intermediate value theorem tells us. All right, so the last problem we're going to do is try to come up with a formula for the polynomial shown. So in order for us to come up with a formula, let's look at our intercepts, because that's usually what we look at first anyways, right? So here we have an x-intercept, here we have another one, and we have another one. So for x equals -3, what's happening? It goes straight through. So that means my multiplicity is linear. So I have a multiplicity of 1. Then at x equals 2, we see that it bounces. So we must have an even multiplicity, but the bounce tells me it must be 2. And then at x equals 5, we see that it goes straight through. That's going to be a multiplicity of 1. So now we have our zeros and their multiplicities. So we can work backwards to get our polynomial. So before I even do that, I just want to do a quick recall. Like if you were to solve, let's say you had x plus 1 equals 0. If you were to solve this to figure out what x would be the 0, you would subtract 1 from both sides, and then you get, oh, x equals -1. But notice that here we have the actual answers, and we want to get back to the factor. So notice that what's on the left-hand side is the opposite of what's on the right, meaning here I have a -1 and here this is a +1. So we're going to do the exact same thing. So here, this is a -3, so my factor would be x plus 3. The multiplicity is 1, so we'll leave that. Here we have a +2, so my factor would be x minus 2. And this has a multiplicity of 2, so I'll put my 2 here. Here we have a positive value, so this will be x minus 5. And there we go. And notice that this is in line with the fact that both endpoints are up. So that means that this must have an even degree, which it does, which is 2, 3, 4. So we have even degrees. So if I were to put everything together so far, f of x equals, so I don't know what my coefficient is, so I'm going to put a. So it's going to be x plus 3, x minus 2 squared, and x minus 5. But we can figure out what a is. How can we figure out what a is? Well, we have here the y-intercept, and basically that means f of 0 when x is 0 is -2. So I can plug that in. So f of -2, actually f of 0 rather, equals, well, this is my f here so far, so a times 0 plus 3 times 0 minus 2 squared times 0 minus 5 is what I'll have. And so this is going to be a times 3 times 4 times -5. And this, based on this, should be equal to -2. If I were to multiply these, this will give me 60 times a, or it's -60, equals -2. I divide both sides by -60 to figure out what a is. So that means a is 1 over 30. So that means my polynomial f of x is 1 divided by 30 and that's my answer.